Assalamualaikum. Hi guys. In this video we are going to balance the redox equation in basic solution. So let's do the balancing by following the Rao-Chair steps. So overall it's just the same thing as in acidic solution. And at the end you just combine two half reactions that you got. And once you check the overall charge for both sides, you can see they are the same one. Now we are going to continue with the next step for basic solution, where you have to add OH minus to both sides of the equation based on the number of H plus. This is because you want to form H2O. So OH minus will react with H plus to form H2O. So this is very important. The number of OH minus must be same with the number of hydrogen ions. So let's try example 15, where you have to balance this equation based on basic condition. So I'm going to continue with Rao-Chair, follow the step one by one. So we are going to determine who is the couple. So you got two couples here. However, if you got OH minus here and H2O here, what you're supposed to do, you just ignore them. At least take note that there will be the position of OH minus at the left side, but you don't even know how many of them. Same goes for the water. So in this part, just follow one by one without including them in the half equation. So once you got two couples here, I'm going to choose the most easiest one, which will be IO3 minus to produce I minus. So I got the oxidation number for iodine in IO3 minus, which will be positive 5. So you got here positive 5, and here I minus, you got oxidation number is negative 1. So from positive 5 to negative 1, you can see there is a decrease of oxidation number. So the process will be reduction, indicates SR. And the other couple automatically will be oxidation, O. So now I'm going to split them into two parts. I use the second method because it is much more easier. So you will have oxidation and you will have reduction. You don't have to bring OH minus and H2O because I just said before, just ignore them for this part. Now we are going to balance the atoms except for oxygen and hydrogen. So you just keep for oxidation because same value for chromium. Next, you got the same value for iodine as well. Don't take a look at the charge yet. So settle for the atom. Now I'm going to continue with oxygen. So in order to balance that, you have to add water. So you got 3 oxygen atoms here at the left side and 3 goes for the right side. So nothing to do. Now you got reduction, 3 oxygen atoms here, so I'm going to put plus 3H2O. Next, we are going to balance hydrogen. So here you got 3 hydrogen atoms, so I'm going to put at the right side plus 3H plus. And the next one, for reduction, you have 3 times 2, 6 hydrogen atoms, so I'm going to put here plus 6H plus. Now settle for hydrogen. We are going to balance the charge by adding electron right now at more positive side. So you have to calculate the total charge for each side. Now we focus for oxidation first. This compound, the total charge will be 0. And for this part, you got negative 2 here plus positive 3. So you got positive 1 is the total charge at the right side. So at the left you got 0, at the right you got positive 1. So I'm going to put the more positive side, which is at the right side. So how many electrons you need to add in order to get 0? You are going to add 1 electron. So settle for oxidation. Now we are going to go for reduction for the charge. I'm going to calculate the total charge for the left side. You got positive 6 here plus negative 1. So the total charge will be positive 5 at the left side. So now we go for the right side of the reduction. For here you got -1 and here is 0. So the total charge will be -1. How am I going to determine the number of electrons that I should put? I'm going to put at the more positive side, which is at the left side, because 5 is more positive than -1. And next, how many of them for the electron? You are going to calculate based on mathematical way that I've taught you before. So you got 5 total charge here plus with x that you want to find out equals to -1. And then x equals to -6. So negative here means this negative sign for electrons. So it means that you have to put 6 electrons. So I'm going to put 6 electrons at the left side for the reduction. Now let's continue with the electron, the last step, where I'm going to cancel them based on the same value at the opposite side. So you can see the electrons both are at the opposite side, but the value is not the same. So for oxidation, I'm going to multiply all of them by 6. So you will have the new half equation for oxidation. Next, I'm going to cancel out for the 6 electron. And you can see there is a similarity for H plus as well at the opposite side. So cancel means you minus. So you got 6 H plus here, you got 18 H plus here. So 18 minus 6, you got 12 left. So I'm going to combine all the species at the right side for oxidation and reduction. Same goes for the left side. Now we will have this equation where you can see that 12H plus is the one that you got after 18 minus 6. Now we are going to balance in basic solution. So far these steps already until acidic. So I'm going to continue. You got this equation. What's next? You are going to add hydroxide ions based on hydrogen ions. So you got 12 hydrogen ions at the right side and none of it at the left side. So it means that you have to add 12 OH minus for both sides. So you got both sides here 12 OH minus. Then the side that containing the H plus and OH minus, they will mix together to form 12 H2O. 12 here is depending on the number of coefficient that you have here for your equation. So I'm going to continue and I got this equation and I highlight here you got the same species 3H2O and 12H2O. So we are going to simplify the equation by adding up all of these species for water together. So you will have a balanced redox equation for this one. So how do you want to check whether you got the right equation or not? Check the total charge for the left side and for the right side. So you have -13 at the left side and -13 at the right side. So this is how you balance the redox equation in basic solution. I leave it to you try these two so that you can enhance yourself how to do these examples. So that's it for this video. I'll see you in the next one. Bye!